Okay, here we go on our first big truss problem. It's going to be painful. Okay, so we have a truss here. We don't have any of the angles. Sometimes they tell us what the angles are, but we have some measurements of different things, so we can actually figure out the angles because this is the unit that you need your trigonometry skills for. If we want to find this angle over here, right there, this is 3 feet here, and this is 4 feet. You can see it over here, 4 feet. So how do I find that angle? Well, the opposite of that angle, I could do opposite over the adjacent side. And if you remember what opposite over adjacent is, it's tangent. So the tangent of the angle would equal opposite over adjacent. That would be 4 over 3. So make sure your calculators are always in degree mode. But I could do 4 divided by 3, and then I could do inverse tangent, and that would give me the angle. So this angle here is 53.1. 53.1. What's this angle up here? Well, that angle up there would be 90 minus 53.1, because this right here is a 90 degree. And so this angle up here would be 36.9. We'll call it 37. Okay, what about this angle over here? Well, it'd be opposite. It would be 4 over the adjacent 7 would be tangent. So 4 divided by 7, and that's shift tangent or inverse tangent, 29.7. So this is like 29.8, we'll call it. 29.8 degrees. And then I could do 90 minus 29.8, and I would get this angle up in here, which would be 60.2. Okay. All right, so we have all those angles. Let's see, I'm going to erase this down here, see how much I can use on this page. Okay, so the next thing we have to do is look at our support. So over here we have a roller support, this round one over here on the right side. So that means we only draw in one force going either up or down. We're not going to put the arrows on it quite yet. And then over here we have a pin support, so we're going to have maybe a force this way and maybe a force this way. Remember, pin supports you put in 2 forces, and for roller supports you put in 1, and we're going to figure out which way they're going. Okay, so when you start every truss problem, first of all, you fill out all your angles that you can figure out. Get all your angles in there. Put in your reactionary forces for your roller and your pin supports. Get those in there. And then if you remember, we have 3 things that we need to meet right at the beginning. We have summation of all the forces in the x direction need to equal 0. Summation of all the forces in the y direction need to equal 0. Summation of all the moments or the torques need to equal 0. So these are fancy Greek things for this one here is lefts equal rights. This one here means ups equal downs, and this one means counterclockwise and clockwise torques need to be equal to each other. So that's what we need to do right here at the beginning of this thing. Eventually what we're trying to do is figuring out what are the internal forces in each member. But to do that, before we ever even get to doing that, we need to make sure all of these conditions over here are met. Okay, so the first thing we could look at is lefts equal rights. Lefts equal rights. And if you look on this particular problem that we have here, the only left forces that you could see, we're talking about external forces right now. External forces, not the forces inside the members, but any forces working on this truss overall. Right now, I only see 4 of those. I see 500 pounds down, and then I have a force over here, and a force over here, and there's a force right there. So the first thing we would do is you'll do lefts and rights. You do a left and right table. There is something over here going left and right, I guess. We don't know which way it's going, but there's only one of them. There are no other things going left and right, and so they have to be balanced. So if there are no other ones, then this force over here on the left side here actually is 0. there is no force there because there's nothing that could possibly balance that out. So it has to be 0. So we don't really actually have any left or right forces in this particular thing. Okay, next thing would be ups and downs. What do we have here? Well, we have 500 down, and we have a force over here. We'll call this F2, and we have a force over here called F1, and we don't know what those are. They both could be up. One of them could be up, one of them could be down. We don't know. So we need to try to figure it out. So we'll leave this table here for a little bit, and we're going to go to torques. We're going to do counterclockwise and clockwise torques. We're going to make a table for those. Okay. So how do we do this? Well, we have 2 unknowns. So if we're going to figure out torques, we can pick any place we want for our reference point. And we clearly want to choose either F1 or F2 as our reference point so that we don't have 2 unknowns. We don't have to worry about any forces at our reference point. So what I'm going to do is I'm going to use point A over here as my reference point, so I don't have to worry about what F1 is right now. So I want to balance out the torque. So what kind of torques do I have? Well, if I go 3 over, I have a force of 500 pounds going down. What kind of a torque would that cause that thing to spin around? That would go, like around this way. That would be a clockwise torque. So a clockwise torque is going to be 500 times a torque arm of 3. Okay, so that's the only down force I have. So what's this force over here have to be, F2? It actually has to be an up force because we need to balance out that torque that we just got. And the only way to do that is have this be an up force. So we now at least know it's up, so I can draw an arrow onto it there. And how much torque is this force going to cause? Well, it's going to be F2, whatever that is, times, how far over is it? Well, it's 3 and then another 7. It'd be 10. Okay. So what do I have here? I have 10 times F2, and this equals 1,500. So what's F2 going to equal? From this table, I can tell that F2 would equal 1,500 divided by 10 would be 150 newtons. So this F2 over here, I'll erase the F2. I'm going to erase this whole thing here because it's kind of ugly now. There's an up force right here at C of 150. So now I can come back up to my up and down table and I can write in, hey, there's 150 up force there. Now my other up force is must be F1, right? Because there's only one other force on here, and it's over here at F1. And so this right here has to be also an up force. And we actually know what it is, because it'd be 150 plus what equals 500. Well, that would be 350. So we know that there is a 350 Newton force up right there on that one. Okay. I'm contemplating whether I should stop right here and just have you absorb that particular thing, because this is what we have to do at the very beginning. We have to do lefts equal rights, ups equal downs, and then we have to have torques equal, and that way, and we can use all these to figure out what our unknown forces are. We had to figure out there's 150 Newton force up, or whatever, pound or whatever it is, and there's a 350 one over here. Okay, so balancing all those out, get all of our angles on here, get our external forces all calculated and figured out, and then we're going to, from now on, we're going to start figuring out the internal forces. I think I am going to stop right there, and before we actually really get into the truss problem. That's what you do on every single truss problem at the beginning. You got to do your 3 tables. You got to try to balance them out and figure out what all the external forces and all the angles are on the truss. And then what we're going to do in our next couple of videos is we're going to start going around at every single joint. So here's joint A, and then here's B, and here's C, and here's D. And what we have to do is we have to make sure that the forces are balanced around each one of these joints. So we're going to take each little corner kind of separately. I might even take each corner separately in a separate video, maybe even. We'll really kind of draw this truss problem out. So we're on 10 minutes for this video. I think that's going to be long enough. So we're just going to stop it there.